When a machine behaves inconsistently, either you're missing something or you can no longer trust what's inside. In my case, it turned out to be both. When I bought this Maho CNC milling machine, I assumed there was only an issue with the CNC controller. At this point, the control cabinet is completely empty, the servo motors are removed, and the axes can only be moved by rotating the lead screws manually. So this isn't much of a CNC machine anymore. So clearly that early assumption I made was a bit optimistic. So in this video I wanted to explain how I ended up here, why I decided to stop patching things, and how this project became a full rebuild instead of just a quick retrofit. The reason I bought this CNC milling machine is actually pretty obvious. I used to have a small tabletop milling machine, and I just wanted to move on to something with a more industrial rigidity and reliability. And mechanically, this machine is just fine. I mean, it has it has heavy cast iron. The ways look proper. The lead screws are okay, and I haven't found anything that's obviously broken mechanically with this machine. The controller, on the other hand, was a different story. When I bought this machine, I knew the controller was broken, and my plan at the time was, as a first step, to debug and fix the original controller. And when that didn't work, I wanted to move on to Linux CNC with Mesa cards, which actually is a pretty common path for CNC machine retrofits. And at that time, the scope felt really reasonable. Once I started digging deeper, things actually became less and less clear. I ran into issues of which I couldn't figure out whether it was with the software, whether it was with the servo drive, it was with the servo motors. So I did what I do best and I started debugging. And with these kinds of machines, you do that by disconnecting things, reconnecting things, trying different methods to control several components. And I didn't really have a lot of success. I tried several things over weeks. I looked at forums to see if someone had any tips on how to move on, and I was just running out of options for a quick CNC retrofit. Now, to be honest, these servo drives and servo motors are from the 1980s. I don't know anything about them. I only did debugging on the outside, which I know. I didn't open any of the servo motors. I didn't open the servo drive because I just don't know enough about that technology. However, I did come to a point where results became ambiguous. I was no longer debugging. I was just guessing, and I was running out of options for a quick and easy retrofit. At this point, I had three options. The first option would be to send the Indramat servo drive and servo motors to a specialized company which can fix them for me, which is pretty expensive, doesn't guarantee success, and I don't really learn anything from it, which is for me at this moment the primary reason I do this project. The second option would be to just keep patching things, switching things around, keep trying and hoping that this last patch will be the holy grail that will get the machine running. Or what I could do is stop, take a step back and reset the problem entirely. That last option seems more extreme, but it removes something that I personally struggle with, which is doubt. And if the foundation is unclear, then every future problem just, for me, becomes harder to reason about. So I made a conscious decision. Instead of trying to fix a partially unknown system, I would reduce it to something that I would understand. That meant creating a new design, emptying the control cabinet, removing the servo motors, and accepting that there is no quick way back. And right now, what I basically have are heavy cast iron parts stacked on top of each other. And I think that's actually a pretty good place to be at this moment, because every component that now goes back into this machine is something that I reasoned about, I thought about, and that I can explain. Even though the machine looks like it's going backwards, a lot of thinking has already happened. For example, I have created a complete electrical design for the new control cabinet, which I made in SolidWorks Electrical. Not because it's the easiest or the cheapest software, but because it forces me to be very explicit about assumptions and connections and components and all those things. And once it's configured properly, it actually does a lot of the work for me, like creating these wire lists, like creating component lists, like terminal diagrams, which I should be able to use once I start building. Mechanically, there are some challenges as well, especially here on the Z-axis. The space for the motor is extremely limited, and I have already made some 3D printed parts just to understand how little the room really is. So let me just mount this motor with the 3D printed adapter to the Z-axis so I can show you how small the space is that I have to work with. Now the motor is in place, you can see that I actually have very little space to work with on each side. I actually had to shift the motor a little bit to the left, while of course keeping the timing belt length the same. And yeah, this still is very much a work in progress, because on this side I have to make sure the cables can be connected. At this moment, when I move the motor all the way back, then the cables nearly touch the cast iron in the back. I have to make sure that the extension shaft that will hold the timing belt pulley will be properly aligned with the motor, because there's very little room for alignment issues. There is very little room to put bearings and all. So yeah, that's still gonna be a puzzle. One other option I have, instead of shifting the axis and putting it at a specific angle over here, is to actually lower this plate about 40-45 millimeters, for which I should have a little bit of space. However, that does mean when I do that, I won't be able to mount the display for the CNC controller on its original location anymore, because then this plate would be down. But when I do that, that would mean I could just mount the motor much simpler with the cables down, just like the original motor. And to be honest, once the Z-axis is solved, then the X-axis and the Y-axis will be much more straightforward. There are some things I'm not gonna do just yet. Like, I'm not committing to any expensive hardware at this moment before I really know that the control side works the way that I expect. And I am sure that the entire design, including the motor adapters, will actually work. For example, before I invest fully, I want to run the Delta servo motor I currently have with EtherCAT and Linux CNC here on the workbench. If I can't get that to work properly, it doesn't make sense to invest any further into this project. Of course, this is just one of the examples that I want to test before I start investing more and more into the project. EtherCAD is an open standard, so I am pretty convinced that it is solvable, but I first want to prove that it works before I commit to the rest. It's not my goal to get this machine running as fast as possible. My intention is to learn from it as much as I can by making deliberate choices and trying to follow industry standards. That is, industry standards we have here in Europe, of course, because I'm in Europe. This starts by removing uncertainty by doing tests before turning ideas into metal and spending a lot of money. In the next videos, I will work on the servo motor adapters, the control cabinet layout, the proof of concept to run the servo motor with EtherCAD and Linux CNC, and finally build everything and get it working. This machine is already past the point of no return, so now I just want it to do right.